Welcome back to Understanding Python. My name is Jake, and today we'll be digging deep into the functionality and uses of named tuples. We'll start off with the basics, then cover methods, comparison to alternatives, touch on inheritance, then wrap up with a practical example. As we go, if you learned something new, let me know by liking the video. Now, let's get started. While not a prerequisite for this video, I originally covered named tuples in my video on the collections module. If you haven't seen that one yet, there will be a link in the description below and the top right now. Now, the general motivation behind using named tuples is typically that it's not always the easiest to work with positional data in tuples. Take this tuple for example. If we look at this, we can see that Bob is likely a name. 25 could be a number of different things, but in this context, we could assume that it's his age. And then the last thing there, heights, we really can't tell, but we can assume that it's one of their fears. Now, if we reference these elements later on in our code, and we wanted to pull out Bob's age, we would use myTuple with an index of 1. If this is close to the definition of the tuple, that's not that bad. We can more easily tell what that is, but assuming that there's a bunch of code in between the two, we may have no idea what myTuple with an index of 1 actually is, unless, say, someone were to add a comment on there. And this is the case that named tuples come in to make it easier to work with positional data like this. So instead what we could do is we could create a new person named tuple class by calling a named tuple factory function that we're getting from the collections module. And this takes a few arguments, but the most important are going to be the name of the class, this being person, followed by the fields of our named tuple. And in here we can put name, age, and fear. And this gives us a new named tuple class. Now, not only can we define it this way, we can shorten this even further. So instead of using a list of strings, we can actually use a single string with our fields separated like this, or even more simply, we can get rid of the commas altogether and have the more succinct version with each of our fields just separated by a space. These statements are equivalent, so it's really up to your personal preference of which one you want to use. For this video, I'm going to go with the last version because it's the most succinct. And now that we have this person named tuple class, it's time to create some named tuple instances of person, and that's going to work basically the same as if we were to create a normal class. So here we have 3 examples. For person 1, we're going to use all keyword arguments, name, age, and fear, all corresponding to the fields that we assigned above. And since these are keyword arguments, we can also put them in any order that we want. Additionally, we can pass these in with positional arguments, not having to specify the age, name, or fear explicitly, but each argument is going to be read into the corresponding positional field. So Charlie would be the name, 35 would be the age, and Charlie's fear is bread. Poor Charlie. And now that we have these people, we can load the file in IPython, give ourselves a bit more room, and start to play around with the data. So here we have person 1, and the string representation of this is really nice. It gives us the field names followed by the values. So to get Alice's fear, we can either say person 1 and the index of 2, or we can just say dot fear, and that also pulls up spiders. And another nice thing about named tuples is that they are completely compatible with tuples, meaning that anything that's expecting a normal tuple can also accept a named tuple. You can even do comparison between normal tuples and named tuples. If we were to compare person 3, Charlie, and see if it's equal to a normal tuple with the same contents of person 3, we see that it is true. Not too bad. Now, before we move on to methods, let's take a moment to look at this person class object itself. And we see that the name of the class is person. We can verify this by checking the _name attribute on the class, and we see it's indeed person. That's because when we created the person named tuple, we explicitly called it person. Now, depending on your use, you don't really have to follow this convention where the name of the variable that you store the class is the same name as the class itself. As a matter of fact, in this example, we just created a different named tuple whose name is same. So depending on the use that you have, just keep in mind that they don't have to be the same thing. Okay, and not only do we have normal tuple methods, but named tuples also have some unique helpers. One of my favorites is we can take any named tuple and call as dict on it. Notice that this does have a leading underscore, so underscore as dict, and convert it into a dictionary, where the keys correspond to the fields of the named tuple, and the values correspond to the value for each field. Speaking of fields, we also have a fields attribute, where we can pull out the names of each of the fields associated with a named tuple. And we're going to use this later on in the video for something special. Now, in order to show this next attribute, we'll modify our file above and add one of the classic tuple examples, which is a point. We'll name this one chords, just to give us a disconnect between the name of the variable and the class itself. And this will have the classic coordinates x, y, and z. But we can also specify some iterable of defaults. So our default position for each of these will just be zeros. Then we'll create two tuples, a start, which would be an instance of a point with nothing in it, and then an end position, which would be another instance of a point with some random position. If we reload the file again, you see we have our start point, which is an instance of the chords named tuple, x, y, and z, all equal to 0, and then our end point, x, y, and z, each corresponding to the values that we passed in above. Now, if we look at start, we can check out the field defaults value. So this is what we specified up above with each of the fields and the default values associated with that. Pretty nice. So with these two attributes, you can get a bit more information about the original named tuple to either build upon later or more accurately get a picture of what you're looking at programmatically. Now, there is an alternate way to construct named tuples aside from just creating instances like we have here. So we had some random coordinate given to us in a list. The values are important, so we'll just give it something roughly in between our start and end, but now we have a poorly written out list. Well, we can create a new instance of our chords named tuple called middle by calling point._make, and we'll pass in that chord list. And now we have middle. So you can use _make, passing in some compatible iterable, and get an instance of that named tuple out of it. Pretty nice. But say that we wanted to change the coordinate. So if we look at middle.y and we wanted to adjust the position, let's try it. Set it to 6. We get an attribute error telling us that we can't set the attribute. That's because, like other tuples, named tuples are also immutable. But there is a helper method available that we can use to do what we want in a little bit of a different way. And for that, we have the _replace method. And in replace, we can adjust any of the values of our named tuple. So we can set x to a completely different value, set it equal to 5, or even z equal to 93. But like I said, it works a little differently because look what we get out of that. We get a new instance of our chords class. And if we look at middle, nothing has changed. That's because, again, the tuples are still immutable. So what replace is actually doing is it's giving you back a new instance that you would then use to override the original, if that's your intention. It's a lot like what we do with string modifications in Python. We don't actually change the string that we're working on. We make a modification to the string data in a new string, and that's what we store as the result. So if we wanted to change middle, we need to store the result of that into the middle variable. And now finally, we get that modification. Okay, now that you understand the basics of named tuples, as well as the helper methods associated with it, let's take some time to compare it to the alternatives to named tuples. Okay, so in this file, I have 3 different versions of this person class. The first version is the named tuple that we defined before, with its fields, name, age, and fear. The second is a classic Python class with the same fields as attributes. And then finally, I have a data class version, again with the same fields. Clearly, classic classes are the most verbose version of the definition, where you have to define a init and explicitly assign each value to the attribute. Data classes come in around the same line, but also have pros and cons depending on if you wanted to enforce specific types on those fields. Pure definition-wise, I think named tuples are a clear winner in this really simple case where we'll just be assigning values to an instance. And if we look down below, we can see that creating instances of each is done in the exact same way. So if we load up this file, we see we have NT Charlie, we have classic Charlie, And then we have data Charlie. Both NT Charlie and data Charlie have good string representation out of the box. However, classic Charlie doesn't. That's something that we would have to implement ourselves. Now let's take some time to look at some performance characteristics. And for this, we're going to use IPython's timeit helper and test the performance of attribute access for each of these. First up will be NT Charlie, and we're going to see how long it takes for us to access the value in its name. And that took approximately 18.4 nanoseconds for the attribute access. Now let's move to classic Charlie. Okay, and classic Charlie came in significantly faster at just 8.02 nanoseconds. So that's more than twice as fast. Moving on to data Charlie. And data Charlie has basically the same performance. So we can see that of the three, nametuples are a bit less performant for attribute access. How about when it comes to creating class instances? Well, we can test that as well. And for our timeit, we'll bring back Alice. And we see that it took the nametuple version 429 nanoseconds on average to create the instance. Moving to classic, that only took 297 nanoseconds. And then finally for data class, 304 nanoseconds. So again, from a performance perspective, nametuples aren't the best option, with classic classes slightly edging out data classes. Do I think this is a good reason to avoid using nametuples, especially in simple cases like these? No. Unless you're writing an application where you're doing a lot of attribute access on these nametuples or creating a lot of instances, the time savings you'd get by avoiding nametuples in favor of classic classes really isn't worth it. So the choice between these three largely comes down to your specific use case, as well as your preference or your team's preference. Since I tend to build a lot more functionality into my classes, I usually go with classic classes, but there's still great uses for nametuples, one of which I'll demonstrate at the end of this video. But before then, let's take a little bit to talk about how you can do inheritance with nametuples. So in this example on screen, I have a nametuple class called RGB, which corresponds to red, green, and blue values. We created an instance of this called cyan. However, if we wanted to get out the values for cyan, since the fields are the words red, green, and blue, we'd have to use the full word for that. Red, green, or blue. Now that's likely fine, but for me, that's still a little verbose. Instead of typing out red, I just want to use R, G for green, or B for blue. Well, how can we do this? We can take advantage of the fact that the RGB nametuple class is similar to other classes in Python. Meaning if we wanted to extend it with a new RGB class, we can inherit directly from RGB, bringing in all that nametuple behavior, and then we can build upon that. And the first way we're going to build upon that is by adding properties for R, G, and B. And we see that here. So when a user accesses the R attribute, we're returning self.red, effectively creating aliases for each of those. Additionally, if we wanted to convert the RGB into a hex value, we can do that like this with a new property. And for that, we're going to use a little bit of string formatting magic to give us the hex format that we're wanting. Notice that in here, we're using self.r, G, and B, the aliases for red, green, and blue. And now we can change cyan from instead of being an instance of RGB to new RGB, give ourselves a bit of room to work with. And we can see that cyan not only has red, green, and blue in there, it also has R, G, and B. So we can pull out the blue value verbosely, or we can shorten that up to B. We can also get the hex value of cyan with the calculated hex property. Not too bad. But I'm not fully happy with this, because right now, cyan is an instance of new RGB instead of just RGB by itself. Now, while we could override RGB with this new class, inheriting from the RGB nametuple class above, that can be a little confusing for people reading it. To ease this confusion, since defining a nametuple class is so short, we can just steal the definition from above and then pop it directly in as an inheritance argument for our RGB class. So we're creating that name tuple class that we're inheriting from directly in the inheritance signature. Pretty neat, right? And that means that cyan can just be an instance of RGB. And if we reload that, we can see that everything else is working exactly as expected. Now, not only can we do inheritance with name tuples like this, using them for more classic style Python classes, but we can also inherit name tuples for other name tuples. But we can also use name tuples for a form of inheritance for other name tuples. We'll still use our RGB name tuple example here as the basis for a new name tuple. And this new name tuple will be called RGBA, which will be adding an alpha channel on top of the existing red, green, and blue channels. To define this, it'll be a lot like defining a normal name tuple, except when it comes to the fields, what we can do is we can steal the fields from RGB and add onto that with a new tuple of fields. This one just being a single new field called alpha. Now, make sure to add this comma at the end to make it a valid tuple. And there we go. At this point, we now have a new RGBA name tuple, which accepts a new alpha channel. So we'll creatively enough create a new cyan called cyan2, which will be an instance of RGBA with the normal cyan RGB values plus a new alpha value of 128. And if we look at this down in IPython, we see cyan2 with its red, green, and blue fields, as well as the alpha field. Now, before we move on to our practical example, I want you to take a look at this RGBA and see how you can extend the behavior to not only allow us to pull out the alpha value that way, but also to pull out the alpha value with the A attribute. If you come up with a solution for that, please paste it down in the comments below. I'm looking forward to seeing your solutions. But let's move on. And for a practical example, I have a CSV file called products.csv with a list of products, specifically a product's name, category, normal price, and sale price. And what I want to do is to load the contents of this file into a list of name tuples with the fields corresponding to each part of the header. So let's look through the solution. Now, the first thing we do is we open the file so we can get a file handler. Next, we pass that into csv.reader so we can get a reader object. And then to pull out the fields that we're going to be using for our name tuple, we call next on that reader. That's going to pull out that top line here, or the header of the CSV. That's going to give us fields, name, category, normal price, and sale price. Now keep in mind that it's going to read these exactly how they are, including the character casing. That is, unless you were to do some additional processing on the fields before passing it into the name tuple. Speaking of which, our name tuple class, called product, is created on the next line. And then the final line here, we just iterate through the remaining lines in the file, and we create instances of that product name tuple class, unpacking the contents of each row. And finally, to prove that everything is loaded in correctly, we're going to iterate over all the products and then print out its name and sale price. So let's run this and see what it looks like. Okay, and there we go. We see all the product names and their current sale price. Pretty nice. Also, if we load this into IPython, we can look at our all products list and see the full name tuples for each of the products in here. Pretty easy. And of course, we can make this a little bit more succinct, but I think this is a pretty readable example. You could even further generalize this by changing the name of the class to instead be the name of the file minus the .csv extension. So this will allow you to programmatically create multiple name tuple classes that you could then load data into. But I'll let you guys play around with that, because that wraps up this video. Now that you understand how name tuples work and know the pros and cons, you'll be better able to determine when to use them in the future. What is your favorite use of name tuples? Or is it something I showed today? Leave a comment down below to let me know. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with this series, please consider subscribing. Thanks for watching.